do a little fun activity that's interactive with Euler's formula. Some of you might have heard of Platonic solids before. The cube is the most, obvious one. There's 5 of them, and we'll be getting into that later in another corner edition. But for tonight, we're going to do something a little fun, just to kind of see what Euler's formula is all about. So what we're gonna do is we're gonna do a sketch or a doodle. Okay. So in a minute, with your pencil and pen or paper, I'm gonna get you to draw a doodle, and it can be any doodle at all on your page. The only problem is you can't lift your pencil off the page. So for example, I could do a doodle where I start here and I circle around and I come down here and I come back up and then I end, and wherever I end I put another dot. Okay? Now you could decide to do a really simple doodle. You could just do, okay, something that looks like a snake almost, or an S. But the point is you just don't lift your finger or your pencil off of the page until you're done from start to finish. Okay? So I'll give you a minute to do that. Okay, excellent. Now what I'm going to get you to do, okay, is I'm going to get you to put dots wherever the lines intersect each other. So in this doodle right here, there would be an intersection here, so I'm going to put a dot here. I would put a dot at this intersection, and then I'd put a dot at this intersection. So I'd like everyone to do that right now. Next, what we're going to do is we're going to shade in the spaces that have been created by our doodles. Okay? So for this doodle here, there's a space here, so that's 1. There's another space here, so that's 2. And then there's a third space here. These are called bounded spaces. But there's also another one, an unbounded space. It's all of the area outside of your doodle. Okay? So if you can imagine this space outside is also something that we're going to keep in mind. Okay? Now if you did a doodle like this one, there'd only be one space, right? Okay? Just an outside space. There's no bounded spaces. Okay, so the next thing we're going to do is we're going to call, okay, we'll call these dots, okay, we'll call these faces, and we can call these whatever we want, lines or squiggly lines, it doesn't matter, okay? And what we're going to do, okay, is we're going to count up the number of each of those things, okay? So faces, dots, and lines. Okay. So we can do one together with me before, and let's see, how many faces do we have? We have the 1, 2, 3, and then we have the outside 4. 4 spaces. How many dots do we have? The best way to do this is to go 1, 2, 3, 4, and 5. Everyone agree with that? Okay, so we have 5 dots. Now for lines, I find this is the trickiest one. You're going to go 1, 2, 3, where did I go next? Let's say 4, 5, 6, 7. Okay? Now everyone, I want you to add your dots to your faces, and then the answer you get from that you're going to subtract from the lines. Okay? So that would be 4 plus 5 is 9, minus 7 equals 2. Okay? And at this point, I'd be asking everyone at home, how many of you got the answer 2? And I would assume, unless you made a little mistake counting, all of you would have the number 2. And that's because this is something that's constant, okay? In any time you draw a doodle on a two-dimensional space like this, okay? And it even works for Platonic solids, okay? If you did the same thing, counted up all the faces of a Platonic solid like a cube, counted up all the vertices, okay? and then counted up all the edges. And then if you did this formula, okay, basically what we've said is faces plus dots, okay, minus lines. No matter what you do, it'll always equal the number 2. Okay? So we've just created a formula. And we can test it with the most simplest doodle I could possibly do, which would just be a dot. Okay? How many faces do I have? I have the outside of the dot, which is 1. How many dots do I have? I have the 1 dot itself. And I don't have any lines, so I put in 0. So 2 minus 0 still equals 2. So it even works for the most basic, okay, I can do. I can do another one just to test it even further. I could do one where I take a circle, okay. What this gets into, you can try it out with a triangle, okay. You can try it out with a square, okay. And no matter what you do, you'll always end up, okay, with the answer 2. So that's our installment today. I hope everyone enjoyed themselves. I like to think of it as a little bit of magic. Now, before we leave, the last thing I want to ask is, why would this be important? Well, let's say I was somewhere else and someone told me how many faces there were and how many lines there were in their doodle. Okay? So I knew the faces and I knew the lines. Well, now I can solve for the dots. I can find the variable. So it's a concept that we use all the time in algebra, and it gets even more complicated when you get into some of the other shapes, okay, some of the other platonic solids, but it works for all of them. You'll always end up with 2. So I hope you enjoyed yourself, and have a good evening.